Today we're on the second worksheet, and so we have another 4 polar graphs to do. Um, for this first one, I'm not going to list out all of the nice angles to plug into sine because we're not doing any complicated math with this. So on the first worksheet, I listed out sine of 0, sine of pi over 6, etc. But I think we can go straight to the table for this one. Now that we've graphed quite a few of these, hopefully you're remembering which angles make sine come out to 1 and 1/2 and 0. So we always start at 0 no matter what. 1 minus the sine of 0 is equal to 1 minus 0. So we face 0 and we plot a point at 1. And then another nice angle is pi over 6. And so that's 1 minus the sine of pi over 6 is 1/2. So we face pi over 6, which is out here, and we go out a half unit. And then pi over 2 is the next nice angle. So that's 1 minus sine of pi over 2 is 1. That's equal to 0. My pen is acting up, so I'm going to try to recharge this here. All right, so we face pi over 2, but go 0. So far we have this happening. And then the graph, we would pick 5 pi over 6. Now we're in quadrant 2. That's again going to be 1 minus 1/2. So here's 5 pi over 6. Go out a little half unit. Like that. And then we can plug in pi. 1 minus 0 is 1. So we have a little bit of symmetry going on. It's weird that there's sort of this, it looks like a bounce happening. But remember, some of these are cardioid shapes. And so this is going to be one of those cardioid. It should look like a heart. All right. Next angle is 7 pi over 6. So now we're in quadrant 3. We would get 1 minus negative 1/2. So that's 1.5. So if I face 7 pi over 6, I go forward 1.5 units. So I'm kind of out here now. And then I'm going to put in 3 pi over 2. 1 minus negative 1 is 2. So face 3 pi over 2 and go forward 2. And maybe you can do the last point with symmetry, or you can plug in 11 pi over 6. That's again going to be 1 minus negative 1/2, which is 1.5. But see how this point is at the same length away from the origin as this point. So that's what I mean by using symmetry. And then if we plug in 2 pi, we get back to where we started. So a little cardioid there, little heart-shaped polar curve. Now for this one, I am going to write out the values, the nice values for cosine, because we have a cosine 3 theta. So remember what this means. There should be 3 petals. This is a rose curve. It's cosine, so the first petal is going to start at the tip of the petal on the x-axis. I know that the length of the petal is going to be 4 units. And so I just need to figure out what are the angles that I should be plugging in here. So we know that cosine of 0 is 1. Cosine of pi over 3 is 1/2. Cosine of pi over 2 is 0. Cosine of 2 pi over 3 is negative 1/2. And cosine of pi is negative 1. So this should be enough to get us started. And then what we're saying, though, is that 3 theta is equal to 0. So theta is equal to 0. And 3 theta is equal to pi over 3. So theta is equal to pi over 9. Now that's a weird one. Pi over 9, I'm okay with plotting, like if this is pi over 6, I could estimate where pi over 9 is. Pi over 12 is halfway, but I'm not really too worried about these angles if they're strange like this. So if we get pi over 9 or pi over 18 or something like that, I might leave this angle off. But I'm just going to list it out so I know that that would be where the pi over 9 is going to be where the width of the petal is. 3 theta needs to equal pi over 2. So theta is pi over 6. 3 theta needs to equal 2 pi over 3. So again, 2 pi over 9, that's kind of a weird, where is 2 pi over 9? I just don't want you guys to spend too much time worrying about where all of that would fall. So we probably won't plot those 2 points. 3 theta Don't know what's going on with my stylus today. Try to fix this here. All right, so 3 theta equals pi, so theta equals pi over 3. So this is enough information to tell me I should be plugging in 0, pi over 6, pi over 3. I will always plug in like pi over 2s and all of the non-quadrant angles. So that's enough to get me started as far as making my chart. So 4 cosine of 3 theta. And we'll talk about some other patterns as we get this graphed. So we always start at 0. That's 4 times cosine of 0, which is 4. Remember, I said that the pattern that we know is that a cosine rose curve starts on the positive x-axis there. So this face 0, go 4. And then I'm going to plug in. I'm not going to worry about pi over 9. Let's do pi over 6. So 4 cosine. If I plug in pi over 6, it's 3 pi over 6. So that's pi over 2. So that's 4 times 0. All right, so I know that so far the petal does something like this. And again, for the width, I don't know how wide it needs to be, but this is one where if the width of the petal doesn't come out to a pi over 6, a pi over 3, pi over 4, maybe pi over 12 angle, then we're not really going to be too worried about its accuracy. All right, pi over 3 is the next angle. That's 4 times cosine of 3 pi over 3, so pi. 4 times -1 is -4. So we face pi over 3, but we go back 4 units. 1, 2, 3, 4. So here's the tip of the next petal. Remember, rose curves have this pattern. Like cosine will always start here. It should always dip down somewhere near the third quadrant. And then what do we plug in after that? Well, remember, we're at pi over 3, so the next should be pi over 2. That's going to be 4 cosine of 3 pi over 2. Cosine of 3 pi over 2 is 0. So I'm going to come back to 0 here. Okay, and then I need to plug in quadrant 2, both the pi over 3 and the pi over 6. So 2 pi over 3. And actually, well, no, hold on, let me finish this. So 4 cosine of 3 times 2 pi over 3 is 2 pi. That's 4. So face 2 pi over 3 and go out 1, 2, 3, 4 units. So now the curve comes up this way. Now, do I need to plot any more points? I don't think so. I'm supposed to have 3 petals. I've got 3 petals showing. So I know that the next point is going to come back down to the origin, and then it's going to finish out right here. You could plot more points if you want to confirm that. Another thing to notice, another pattern to notice, is that if you know where the first petal starts and you know how many petals there are, you can find the distance between petals, right? Like if there are 3 petals, 2 pi is a full circle, divided by 3 means, yeah, the distance from this petal to this one was 2 pi over 3. And then you can go another 2 pi over 3. And you might be saying, well, how do I know how far 2 pi over 3 is? Just count how many sections it is. Use the picture. 1, 2, 3, 4 sections to get from this petal to this petal. 1, 2, 3, 4 sections to get from this petal to this one. And 1, 2, 3, 4 from this petal to this one. So use the symmetry to your advantage. Check that these look right. If something is off, you'll know you made a computational error somewhere or just plotted a point wrong. All right, here's another rose curve. Again, 3 petals. This time it's a sine graph, so it's going to start somewhere here in quadrant 1. We'll figure that out. 3 is the length of the petals, so they're going to go out to 3 instead of 4. And we can do the same thing to figure out what angles we need to plug in. Sine of 0 is 0. Sine of pi over 6 is 1/2. Sine of pi over 2 is 1. Sine of 5 pi over 6 is also 1/2. And sine of pi is 0. So sine of 0 is easy, but for the rest of these, we could say, okay, 3 theta should equal pi over 6. So here's another one. Am I really going to worry about where pi over 18 is? Probably not. If that were pi over 12, yes, because it's easy to mark off halfway between pi over 6 and 0. But pi over 18, It's easy to mark off a third of the way here, but then it gets a little, you kind of have to be careful. And again, I'm not too worried about the width of the petals for these. The tips need to be accurate, not necessarily the widths. 3 theta is equal to pi over 2. That means theta is pi over 6. So we need to plug in our pi over 6 angles. 5 pi over 6 equals 3 theta. Again, 5 pi over 18. I don't want to spend time worrying about where that is. 3 theta equals pi, so pi over 3. So basically, when it's 3 theta, whether it's sine or cosine, we have to plug in both pi over 6 and pi over 3 angles and all the non-quadrants. Okay, this time we're going into 3 sine 3 theta. We always start at 0. That makes this 3 sine of 0, which is 0. So the sine rows curves always start at the origin. And then we're going to plug in pi over 6. So that's 3 times the sine of 3 pi over 6, which is pi over 2. 3 times 1 is 3. So at pi over 6, 1, 2, 3, we're out at the tip of the petal. Now remember what I said. If I know where the first petal starts, I should be able to find the other two. I could say full circle is 2 pi divided by 3 petals. That's how far apart the tips are. So if you think about, let's see, where's 2 pi over 3? Let's just check this and see if this works. 2 pi over 3 is 1, 2, 3, 4 sections, the way this graph is labeled out. So I should be able to go 1, 2, 3, 4. The next petal tip should be here. 1, 2, 3, 4. And then 1, 2, 3, 4. So it should be this. But let's confirm that with our math just to be sure. So I plugged in pi over 6. I got 3. So far I have this. And then I plug in pi over 3. 3 times the sine of 3 pi over 3 is 0. We're back here. And then we get pi over 2. 3 times the sine of 3 pi over 2. So that's 3 times negative 1. So we face pi over 2, but we go down 3. So that was right. Clean this up. This curve looks kind of messy there. Okay. And then we plug in 2 pi over 3. That's going to be 3 times the sine of 2 pi, which is 0 again. So back here, I think this is working. And then 5 pi over 6. That's going to be 3 times the sine of 3 times 5 pi over 6 is 5 pi over 2. 5 pi over 2 is the same position as pi over 2. So that's 3 times 1. So face 5 pi over 6 and go out 3. Yep, and then we're going to get back to the center. So you can use a little bit of geometry to help you out too. I had that graphed pretty quickly. What if I would have gone with just the petal tip thing? And then you just need to draw in your petals kind of with a smooth curve like this. Yeah, so that's pretty good for that curve. All right, number 4 is not a rose curve because it has something being added to it. So we're going to go back to just plugging in some nice numbers here. I don't think I need to write out all the cosine values because it's not cosine of 2 theta or 3 theta. So I'm just going to plug in from memory what the nice angles are for cosine. We always start at 0. We get 1 plus 2 times the cosine of 0, which is 1. So we face 0 and we go out 3. The next nice angle in quadrant 1 for cosine is pi over 3. 1 plus 2 times the cosine of pi over 3 is 1/2. That's 1 plus 1, which is 2. So we face pi over 3 and we go out 2 units. And then we'll go up to the top of the circle, pi over 2. 1 plus 2 times cosine of pi over 2 is 0. So face pi over 2, go out 1. Then 2 pi over 3. 1 plus 2 times negative 1/2 is 1 minus 1. So we're to the origin here. So here's what we have so far. The graph starts here and then curves around. And then if we plug in pi, we get 1 plus 2 times cosine of pi is negative 1. So 1 minus 2 is negative 1. So face pi, but go back 1. So this is one of those, is it a lemicon? with an inner loop. And then we get 4 pi over 3. Now, maybe at this point you realize what the shape is going to be and you can do symmetry. But if you're not confident in those shapes, just keep going. So 1 plus 2 times the cosine of 4 pi over 3 is negative 1/2. That's 1 minus 1 is 0. Back here. And then 3 pi over 2. 1 plus 2 times 0 is 1. So face 3 pi over 2, go down 1. Maybe now you're convinced that there's symmetry. So you could say, all right, the next point is on the pi over 3 line and it's forward 2. And then the graph should complete at 2 pi. If you're not confident about that, then the next thing you plug in is 5 pi over 3 and then 2 pi. All right, hopefully you're getting more comfortable with these graphs. Remember, it's just sort of about kind of plug and chug, pick some nice numbers and plug them in, see what you get.